So we have the average rate of change. We got this new formula here, and then we have our old 9th grade formula, which again, I would write beside this that this is, I hopefully already did this, y2 minus y1 over x2 minus x1. And now we went through the instantaneous rate of change, which is the slope of the tangent, which is the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Now, we call this the derivative. Now, the derivative has notation. So we're going to talk about that notation next. But before I do this, instantaneous rate of change, when we talk about instantaneous rate of change in this class, because that's a mouthful, we're no longer going to call it instantaneous rate of change. We're actually going to call it slope. Now, some of you are going to have a hard time with that because you're going to be like, well, does that mean slope from 9th grade or does that mean slope now? When we say slope in calculus, it always means instantaneous. Instantaneous is always preferred over average. So if I say slope, what does it mean? Instantaneous. And instantaneous is what we call the derivative. So anytime you see slope, just know, hey, that means instantaneous rate of change, which really means derivative. Okay? They're all synonymous with each other. Instantaneous rate of change is slope, which is also derivative. Now, the notation for the slope of the tangent line, which is instantaneous rate of change, which is slope of the tangent line, is called a derivative. Now, the derivative has many notations. Here's one notation. That is right there, f prime of x. F prime of x, and it's an apostrophe after the f. And f prime of x, that prime just means the derivative of function f. It means you've done something to function f. It means you've found the derivative of function f, and you're saying it equals this. Now, there are many notations, and I want to look at them before we do our example, because you're going to see them. Might as well get you familiar with them. Here are all the common notations for a derivative. There are many notations to denote the derivative of a function, which just means instantaneous rate of change, or slope. Okay? Again, this is just slope, slope of the tangent line. This is instantaneous rate of change. There are many notations to denote the derivative of a function, y equals f of x. The most common is f prime of x, but here's a list of all the common notations used, and they are all used on the AP exam. Every one. Okay? The first one, f prime of x, just means the derivative of function f. Y prime, that kind of makes sense because f of x is really y, so if we're going to call it f prime, we can also call it y prime. Okay, so just another notation. This one's my favorite. These are faster, but this one's my favorite, dy dx. Let me tell you what it means. It means the derivative of y with respect to x. It means the derivative of y with respect to x. And the reason it's with respect to x, the d right here means we're actually going to differentiate x. X is actually what we're going to perform the derivative on to find the derivative of y, because y is going to be in terms of what? X. Our equation is going to be y equals to. So it's going to be y in terms of x. So we're actually going to find the derivative of y, but it's actually x we're actually going to be deriving, or we're performing the derivative on. Okay? Df dx is just, you don't always have to call them y, you can call them any kind of function. So the derivative of a function with respect to x, same thing. And this d dx means the derivative with respect to x of some function. Just a different way of writing it. A lot of times this is how you'll see your derivative rules written. They'll say the derivative with respect to x of whatever rule you want to apply. So maybe it's a trig function in here, maybe it's a composite function, maybe it's a product, maybe it's a quotient, maybe it's a sum or difference, maybe it's a constant, maybe it's whatever. Okay, and then you get your rule. You state your rule, which we're going to start developing next week. All right? Okay? All right, let me do an average rate of change problem, because you literally, oh, I hit the button. That wasn't good. Let me go back. So, oh, that was the other one from before. So look down here at the example. Let's do two examples. Let's do an average rate of change example, and then we'll do a derivative example. Let's start with the 9th grade one. It says this. Find the average rate of change. Now, from now on in calc, since we're always going to assume slope means instantaneous rate of change, which means slope of the tangent line, which means derivative, in order for us to do 9th grade slope again, they're going to have to say it. And the way they'll say it in calculus is always average rate of change. That's how you'll know. If they ever say average rate of change, you're like, sweet, I can be a 9th grader again. It's time to reminisce. Okay? It's time to think to the good old days. All right? So we're going to reminisce for a second. Let's go back to 9th grade. Think about when you're in my class, okay? Candy was just a little guy, all right? So find the average rate of change of f of x equals x cubed minus x over the interval from 1 to 3. Now, this is from x equals 1 to x equals 3. Now, how did you do 9th grade slope? What did you have to do 9th grade slope? Don't make this problem hard, because I will send you to timeout. You find the points. So I want you to think about this. This is a graph, okay? Right? Let's jack up this graph real quick. A lot of you don't know how to graph this because it's kind of a common function, but it's not. It's not x cubed, it's x cubed minus x. Somebody like, well, how do I graph something like that? Well, it's positive x cubed. What do I know about positive x cubed? Down to the left, up to the right. So I at least know that. Then what you could do is you could real quick find where it crosses the x-axis. How can I figure out where this crosses the x-axis? How can I find the zeros of the function? Set y equal to 0. I could set the equation equal to 0. And can anybody tell me what I can do with that? Factor out an x. I think somebody said it. I'm just going to go with it. Factor out an x, we get x squared minus 1. And then what we get is x times x minus 1 times x plus 1. And we get it all factored completely. And we find out it equals 0. 3 different places. Where does it equal 0? Yeah, 0. And then where else? X equals 1. And then where else? X equals negative 1. And that's the 3 places it crosses the x-axis. So when you graph it, you're like, okay, sweet. You got negative 1, it crosses. You got 0, it crosses, and you got 1. And then what Canyon said was right. It goes up to the right. It goes down to the left. So what do you think happens in the middle here? The only way it's going to work, it's going to have to go up, come back across, and then go down and come back across. Now, I don't know how high and low it goes, and I really don't care right now. We're going there soon, okay? Coming soon to a class near you, we will go there. We will figure out how high and low it goes, I promise you. That's very interesting. It's very, very useful. It's called finding relative extrema, maxes and mins. And it's very, very important in the real world. You think business doesn't want to know what the max and min are? You're crazy. Okay? They want to know what the best they did this quarter. They want to know what the lowest we did this quarter. They want to know those kind of things. They want to know what's the best hours of production at work. They want to know which shift is getting the most done, and which shift is slacking. Is it the night shift or is it the morning shift? Okay? When are we busiest? Okay, especially if you're a 24-hour place. When do we need the most employees? When do we need less employees? If we're a restaurant, when do we need more waitresses and waiters? When do we need less? If you don't think they want maxes and mins, you are absolutely outside your mind. This is very, very useful. And we're going there, okay? But we got to get a derivative before we can go there. So this is what it looks like. Now you can kind of imagine what we're doing. Now you can say, oh, I want the average rate of change from 1 to 3. Okay, there's 1. Over here's 3. That was not a very good secant line, but just go with it, okay? I want to know the slope of that secant line. That's what I'm after. That's what average rate of change is. It's just the slope of that line through those 2 points. All I need to know is what those 2 points are. How do you find those 2 points? Plug in 1, you're going to get f of 1. And what's that? That's 0. Plug in 3, you're going to get what? 24. You'll get 27 minus 3, which is 24. Okay? And if you like writing the points this way, that's fine. We're big boys and girls, though. I hope we can understand it this way now. Okay? And then we just calculate slope like we did in 9th grade. Now, if I'm going to write it out like our definition, I'm going to make this really a lot more complicated than it seems. But I want you to get used to the way we write it in calc. The way they write the slope of the secant is they literally write f of b minus f of a over b minus a. Well, just understand, this is your a to b. So there's your f of a, f of b. Well, what is f of a? F of a is this. F of b is this. So then when you do this, you're just like, okay, this is just really f of 3 minus f of 1 over 3 minus 1. That's what average rate of change is. y2 minus y1 over x2 minus x1. Now, a lot of you will just speed up and say, oh, well, f of 3 is 24. I don't need to write f of 3. Minus 0 over 2, and what's 24 divided by 2? 12, and there's your average rate of change from the interval from 1 to 3. Really not too different. Now the next part, this is where it gets interesting. That's like, not even that cool, because we did that in 9th grade. We want to be cooler than the 9th grade kids. Okay, so what we want to do is we want to find the instantaneous rate of change. I've got 5 minutes to do this, so you need to pay attention. It says find the slope. What does slope mean now to you? It means instantaneous. So now this means the slope of the tangent. So I want to find the slope of the tangent of the graph of the parabola y equals x squared at the point 24. This is actually a 2-part question. And actually a 3rd question if you go down to write an equation for the tangent line. So let's just start with the first question. Find the slope of the parabola y equals x squared at the point 24. Let's just visualize what we're after here. All I gotta do is quick. I'm going to make a video, one more video of a problem for an example this weekend, so when you go to do your homework, if you get stuck, you'll have something to look at. So the point 24, 1, 2, it's up here. I'm interested in the slope of that tangent line. Now I already told you what will calculate the slope of any point on the graph. What formula will calculate the slope at any point on the graph? The slope of the secant with the what in front of it? The limit in front of it. So this formula right here is a formula that will come up with something that will allow you f of x plus delta x minus f of x over delta x. This formula, what it does is it calculates the slope of any tangent line. So if it'll calculate the slope of any tangent line, do you think it'll do it for the point 24? Yeah, so now what we got to do is run this equation. What the first step is you got to run your equation through this formula. You actually got to figure out a formula that'll calculate the slope for all points. And then after you do that, you can do your specific point. Okay, so let's try it. Here we go. Limit as delta x approaches 0. We're okay. All right, f of x plus delta x. Help me here. This is f of x. This is really f of x equals x squared. So what would f of x plus delta x be? What now? Be careful. I want to take this and actually plug it in for x. So I need to take the x out and plug the whole quantity in. So what is it going to be? Yeah, so it's going to be x plus delta x quantity squared, which means you're going to have to FOIL it. So you're actually taking x plus delta x and you're replacing the x with it. You see that? Minus, go to the next part of the formula because this part is done. Minus f of x. What is f of x? That's just the function, x squared. All over delta x. Delta x is just given. It's just a part of the formula. All right, so now we got the limit as delta x approaches 0. How dare they? All right, x plus delta x squared. Who remembers how to do this? If I'm going to figure, this is just going back to our test now. Now we're back to what we were doing last week. We're just finding a limit. Can I calculate this limit value? Yes, you know how to do limits. Well, I try what first? Direct substitution, but the problem is you get 0 in the denominator. And if you substitute 0 on top, you're going to get x squared minus x squared, which is also 0. So you got 0 over 0, which means there better be some algebra you can do. What kind of algebra can you do on this problem? FOIL it. What's this end up being?
X squared
Plus 2x delta x. Yeah. Get it right? Plus delta x squared, just minus x squared all over delta x. Now, I told you a couple weeks ago, if you do this right, everything that has not a delta x will what? If it doesn't have a delta x, it's going to cancel. What is going to cancel? X squared. Let's see it. Slash and burn. Boom. Boom. X squared gone. So now we have the limit as delta x approaches 0. We haven't taken the limit yet. 2x delta x plus delta x squared over delta x. What's the next step? Factor out a delta x. So now we have the limit as delta x approaches 0 with a delta x factored out, 2x plus delta x all over delta x. What happens at this point? The delta x's cancel. Isn't that awesome? So then we can put 0 in for delta x, and what do we get? Well, this goes to 0, and then we're just left with 2x plus 0. There's no more delta x left, so you get 2x. You know what this is, ladies and gentlemen? This is a formula that will calculate the slope of every tangent line on that graph. That means the equation 2x is the derivative of x squared, which calculates the slope at any point. Well, I want to know the slope at the point 24. So how can I use that formula to calculate the slope at the point 24? Plug in what? 2 in for x. So what's the slope? That slope right there is 4. There you go. That's slick.
That's cool.
Isn't that cool?